Good morning. We're going to do back substitution today. So we have some examples here that, let's move these around. So we're going to have a system of 3 equations today with 3 variables. So we're going to solve for each. The steps are listed right here. Let's go ahead and start with the example number 1. This one we already know what z is, so we're going to start by taking z and substituting it into the 2 other equations. So the first step, I'm going to go ahead and say is x minus 2y plus 3z, and instead of z, we're going to replace that with a 2. Okay. Equals 9, and then the second equation, y plus 4 times 2 is equal to 7. And then I already know I can keep my z is equal to 2. All right, so simplifying that, I get x minus 2y plus 6 is equal to 9, and y plus 8 is equal to 7, and z, we already know that z is equal to 2. So when you know the value of a variable, you can just we can back substitute it in, and then we have a system with fewer variables. Okay, so I'm going to go ahead and subtract 6 and subtract 6 and subtract 8 and subtract 8. So I get x minus 2y is equal to 3, and y is equal to -1, and z is equal to 2. So now we have 2 of our 3 variables solved. So we can go ahead and substitute y into our top equation, and then that'll isolate our x. So here we go. Second variable, x minus 2 times -1 is equal to 3. We get x plus 2 is equal to 3 minus 2. X is equal to 1. So our system looks like x is equal to 1 now for the top equation. The middle equation we solved for y, and the last equation was our variable z. So we write that the solution to the system is the pair 1, -1, 2, where the order goes x, y, z. So an xyz coordinate is a coordinate in 3 dimensions. So we all know of our x and our y planes. The z plane comes out towards us to make a 3rd dimension. Okay, so there is our solution. Let's go ahead and look at number 2. This time we don't have any of the variables solved for. So what we're going to do is pick 2 of the equations and eliminate one of the variables. And then we're going to use the 2 other equations and eliminate the same variable. And we're going to create a new system. So let's go ahead and do that. So I'm going to start with the top 2. I can already see that if I just use elimination method, that the 2 x's are going to cancel each other out. So because the coefficients are the same, so I'm going to go ahead and write that this is x minus 2y plus 3z is equal to 9, and -x plus 3y plus z is equal to -2. Okay. When I add these, I get a 0, and then -2 plus 3 is y. So plus 3z plus 1z is 4z is equal to 7. All right, we're going to hold on to this for a second, and then we're going to switch over and grab the 2 bottom equations. So these 2 right here, okay? And we're going to set we're going to do the same thing. So negative x plus 3y plus z is equal to negative 2. And 2x minus 5y plus 5z is equal to 17. Now we want to eliminate the x. So to eliminate the x, I'm going to multiply the top equation by 2. That leaves me with negative 2x plus 3y, plus 6y plus 2z is equal to, because I'm distributing, negative 4. And then the bottom equation, I didn't have to multiply by anything, so I'm just technically multiplying by 1. We go ahead and we add those up, and we get 0. 6y minus 5y is 1y, plus 7z is equal to 13. Okay, now I have two equations that have two variables, so I can just set this up as a new system. Like so. So we're going to take these two equations and set them up as a new system. Okay, so I have y plus 4z is equal to 7, and y plus 7z is equal to 13. So now that I have two variables, I can solve a system like normal. I'm going to go ahead and use elimination method, multiplying the top equation by negative 1. So that gives me negative y, when I distribute, negative y minus 4z is equal to negative 7. Bottom equation stays the same, so y plus 7z is equal to 13. Add those up. I get 0y, 3z, and 6. Isolate the z by dividing by 3. So z is equal to 2. Woot! Now we have one of our variables solved for. We know z is equal to 2. Okay, so the next part is we're going to back substitute. So I'm going to take my original equations. X minus 2y plus 3z is equal to 9. And anywhere there's a z, let's put these out. 2 and 2x. Oh, wait, I forgot. Just kidding. Now that I know my z variable, I can solve for my y variable. So I'm going to go ahead and do that now. Right here, you choose either equation. So I'm going to just choose the bottom one. Y plus 7z is equal to 13. I'm going to isolate the y because that's what I'm going to isolate the y because that's what I want to solve for. So I'm going to subtract 7z from both sides. I get y is equal to 13 minus 7z. And then I remember that z is equal to 2, so I can substitute that back in. Y is equal to 13 minus 7 times 2. So y is equal to 13 minus 14, which is y is equal to negative 1. Oh, second variable solved for. Love that. We just need to solve for the third variable now. And so what we're going to do is choose one of the equations. Since I have z and y, I can go ahead and just go back and choose one of the originals and substitute in z and y to isolate x. So I'm going to go ahead and choose the top equation just because it's easiest to see. So I have x minus 2y plus 3z is equal to 9. And I know that y is equal to negative 1 plus 3 times 2 is equal to 9. Now we just isolate the x. X is plus 2 plus 6 is equal to 9. So x plus 8 is equal to 9 minus 8 minus 8. X is equal to 1. So now I have the ordered pair, x, y, and z, of 1, -1, and 2. Woohoo! Yeah! Okay, last one. Ugh, my iPad scrolls a different direction now. Confusing. Okay, last one. So I have x minus 3y plus z is equal to 1, 2x minus y minus 2z is equal to 2, and x plus 2y minus 3z is equal to -1. So I'm going to use the top two equations first. Sorry, I mean the top and the bottom equation first, because I noticed that there's the x and the x, so I don't have to multiply by anything really to isolate. Or I'm only going to multiply by -1 actually. Okay, so I'm going to go ahead and write this out. We have x minus 3y plus z is equal to 1, and x plus 2y minus 3z is equal to -1. To use elimination, I'm going to multiply the top equation by -1, which is going to change the signs for all the terms in the top equation. Add these up, I get 0x, and then 3y plus 2y is 5y, -z minus 3z is -4z, and then -2. All right, that's my first set where I eliminated x. So now I need to choose two other equations. I'm going to go ahead and choose the top two. It's your choice, but it has to be two different than the ones that we chose already. Okay. So I have x minus 3y plus z. Go ahead and move this. Plus z is equal to 1, and 2x minus y minus 2z is equal to 2. If you're like me and your z's look like your 2's, you might want to put the little crossbar so that they don't look like 2's and you don't get confused. Anyhow, go ahead and multiply the top equation by -2. That gives us -2x plus 6y minus 2z is equal to 1. Oh, just kidding. Is equal to -2. And then the second equation stays the same. So just multiplying by +1. Okay, we're going to add these up. I get 0x, and then 5y minus 4z is equal to 0. Okay, we'll take these two equations with two variables and make a new system. 5y minus 4z is equal to -2. 5y minus 4z is equal to 0. Multiply the bottom by -1, so negative, positive, negative. When I add, I get 0, 0, and -2. So 0 is equal to -2. Remember, this means that there is no solution because all the variables go away. The statement doesn't make sense. 0 does not equal -2. So this is an inconsistent system. And there is no solution. Okay, just a reminder that let's say that at the end, instead of getting 0 is equal to -2, we got something like 3 is equal to 3. So all your variables go away, but the statement makes sense. Then this is still an inconsistent system. And you would have infinitely many solutions. Okay. Last type of equation or type of solution you can get is like if you had a pair, we have 1, 1, 7. This is one solution. That's something special. One solution and a consistent system. So same as a system in 2 variables, the same rules apply for a system in 3 variables. Okay, so I'll see you in class tomorrow. Hope you all have a nice morning.